Okay, class, here we're going to find a function, a sine function that fits data points. So our data points are going to come from the temperature. And so the month will represent X, and the average temperature for that month will represent Y. And so we just need to use these steps to help us find the component parts. So we're going to start by finding the amplitude, and that's just going to be the largest data value minus the smallest data value and divide by 2, since we split it between above the x-axis and below the x-axis originally. So the highest value in our average monthly temperature happens in July at 74.2. And then lowest temperature average is 30 in December. We're going to take the difference and pop that into our calculator. We're going to get 22.1. Okay, so we've got the amplitude worked out. So now we have to find another piece. We'll find the vertical shift next. And to do that, we just take largest data plus smallest data and divide 2. Okay, so this B part is going to be equal to 74.2 plus 30 divided by 2. And if we calculate that out, we should get 52.1. Okay, and now the omega, first of all, if we look at the period, so it starts in January and ends in December. So the period is going to be 12. Okay, because picks back up in the following January after December and begins anew. So since we've got T, and we know that 12 is equal to 2 pi over omega. T equals the original period of 2 pi over omega should equal 12. So that means omega is equal to 2 pi over 12, which reduces to pi over 6. Okay, so we've got the period and we've also got omega now. Okay, so at this point, we want to take our period and then divide it by 4 to figure out what our step is to the next critical point. Remember, we did this before. So if I take the total period and divide it by those 4 intervals that create our critical points, right? Because we went from one critical point here, another one here, another one here, another one here, and then it ends there. So we had 1, 2, 3, 4 intervals. And we know that the first one started at 0, and then there's some y value here. And then this was going to be since our step amount is 3, okay, 12 over 4 is 3. That means the step to our next critical point is by 3. So we know that would be a 3 and some y. And then this would be 3 more. So this is going to be a 6 and some y. And this is going to be a 9 and some y. And finally back to the 12 and some y through one period by our step amount of 12 divided by 4. T divided by 4 gives us that 3. So we're stepping by 3s to each critical point. And this tells us that we should expect a maximum to happen at 3. Whatever y is, we know that the critical point that happens at 3 is the maximum. And if we look at our data, so I'm coming over here to the data, the maximum in our data occurs at July, which is the 7th month. Okay, so 74.2. So we need the maximum to happen at 7 which is 4 more than where our maximum is happening now. So we know that we're going to shift, in this case, by 4 units. Okay, and since our phase shift is described by B over omega, we know that that has to equal 4 in order to get the old max of 3 shifted to where the max belongs at 7th month. So we know that equals 4. And we've already got omega, right? So I can plug in a pi over 6 here. Okay, and then just to solve for phi, I'm just going to multiply both sides by pi over 6. Okay, so phi is going to reduce to 2 pi over 3. Okay, omega pi over 6. A 22.1, B this. So notice we're not missing anything. We can now fill in our parts, and our function is going to be 22.1 times the sine of pi over 6x minus 2 pi over 3 plus b 52.1.